All right, welcome to section 8.3. We're going to look at fractions as our exponents. So a quick review of our exponential rules. Remember the zero exponent rule says that x to the 0 power is equal to 1 as long as your base does not equal 0. And then we have the trick questions. 4x to the 0 power does not equal 1. This is 4 times x to the 0. X to the 0 is 1. Then we multiply it by 4. It's actually 4. Our product rules, when we multiply like bases, we add our exponents. Again, be careful. 2 to the 4th times 2 to the 3rd is not 4 to the 7th. It's 2 to the 7th. The base does not change. Quotient rule, divide like bases. Subtract your exponents, top minus bottom. Again, 3 to the 5th divided by 3 to the 3rd is not 3 divided by 3 is 1. 5 minus 3 is 2. It's 3 to the 2 power. Power rule, x to the m power, all to the n power. It's like seeing two powers, multiply them together. Negative exponent rule, remember there's three parts. X to the negative 1, or excuse me, x to the negative n is take the x, the base, move it down to the bottom with a positive exponent. Or if my base is on the bottom and has a negative exponent, we move it up to the top with a positive exponent. And if I have a fraction raised to a negative power, you just flip the whole fraction and change it to a positive power. Okay, now for our rational exponent rule. Radicals, nth root, m as my power, x to the m over n is equal to the nth root of x to the m. It is also equal to the nth root of x, all raised to the m power. Okay? Now, while we're here, I'm going to load up my iPad here. And I want to talk about how to properly write an fractional exponent. All right, so let me make this a little bit bigger here. Okay. So, don't write x to the m over n power starting your numerator in the exponent. So if I wanted to write 3 to the 1/2 power, now it's kind of looking like a mixed fraction. Yuck. What we should do is write your base. Put your denominator first in the exponent position and build your fraction going up. 3 to the 1/2 power, 3 squared, fraction bar 1. Now I am convinced that we have a fractional exponent. All right. Okay, let's change. One thing that we're going to have to be proficient in doing is we're going to have to change radicals to our fractional exponents and our fractional exponents into radicals. So again, the denominator is the root, the m, the numerator is always the power. Oh, while we're here, before we move on, let me go back to my iPad. And let me tell you when it is a good idea to use the power on the inside and when you should have the power on the outside. Okay, the best time to use your power for m is when you work with variables. So let's clear this page. Let's say I had x to the 2/3 power. This would be a good time. Third root of x squared. Just put the power on the inside of the x. Now, when is it a good time to put the power of 2 on the outside? Well, maybe you have something like 64 to the 2/3 power. That's the cube root of 64. Now, I don't want to put the power of 2 here, because then I got to do 64 squared and make that number bigger. What would be better to do is raise this whole thing to the power of 2. So what do I mean by that is we can take the cube root of 64. We saw that earlier. That's a 4. And now we take 4 squared, that's 16. So it's easier to break the 64 down to 4 than it is to take the 64, square it, and make it bigger, and then try to break it down to all 3 16s. So if you have a number to a fractional power, consider putting that numerator to the outside and break this down to its single value, then square it, cube it, whatever it might be. If you have variables to a fractional power, then put the power inside with the variable. All right, good, get that out of the way. All right, so we'll stop with the iPad. All right, back to our examples here. All right, so root is 3. That's my denominator. Build up, power of 2 on the top. 4th root of 2xy cubed. The authors will tell you to put this whole thing to the power of 1 and write it to the 1/4 power. Then put 1s on the 2 and the x for your powers. And now you have a power to a power. Multiply the 1/4 to each power, and there's your final answer after you distribute it in the 1/4. Well, I say hogwash. Why don't we put the 1s on the 2 and the x here, and then write it 2 to the 1/4 power, x to the 1/4, y to the 3/4, and we can go right to here. So I would do that as a shortcut. Next, we have 3 times the 5th root of a squared b to the 4th. Now 3 is not part of this. So we'll have a to the 2/5, b to the 4/5, and there's my final answer. 7 to the 1/6 power. Okay, 6 to the 6th root of 7 to the 1st power, or just 7. 5x is now the whole base because it's in parentheses, so the cube root of all of 5x to the power of 1. The 3/4 is only on the y, so 3x is going to stay out in front of the 4th root of y to the 3rd power. Okay, simplifying these exponential properties and write them with positive exponents. Now we just have all fractional exponents to work with. So here's my product rule. Multiply like bases, add your exponents, 1/5 plus 3/5, 4/5, done. Dividing like bases, subtract your exponents. 5, 6 minus 1/2. You need a common denominator. 2 goes into 6 3 times, so multiply the top and bottom by 3 and make it 3 6. Subtract it to get x to the 2/6. Wait a minute, we can reduce that fraction one more time. X to the 1/3. Power to a power, multiply. You could make this 6 12s and then reduce it to 1/2, or you can cancel the 3's. 2 can go into 4 twice, and you can get y to the 1/2 that way. 6 to 1/2 dozen to the other, doesn't matter to me. Here we have the power of 1/2. We can multiply it to the insides. Since this is going to have a negative exponent, if you wish, we can go put it into the denominator first. And now simplify. The 2's cancel, leaves me y to the 1/3 on the top. 2 goes into 4 twice, leaves me x to the 2/5 on the bottom. Here we have x to the 3/4, y to the 1/2, z to the 2/5, all over x to the 1/4, y to the 3/8, z to the 2/3. Take them one at a time. X to the 3/4 minus 1/4, x to the 2/4, x to the 1/2. Now do your y's. Y's to the 1/2 minus 3/8. 1/2 is the same as 4/8. Subtract y to the 1/8. Z to the 2/5 minus 2/3. Okay, we're going to need a common denominator of 15. So 5 times 3 is 15. 3 times the 2 gives me 6/15. 5 times the 2 gives me 10. Subtract gives me z to the negative 4/15, but we need positive exponents. Move the z into the bottom below x to the 1/2, y to the 1/8 on the top, then z to the 4/15 on the bottom. Okay, and this one here, x to the 3rd, y to the 5th, all over the 4th root of x to the 3rd, y squared. Change those to fractional exponents, x to the 3/4, y to the 2/4. Now we can apply the same rule we did over here. Divide your x's, subtract your powers, 3 minus 3/4. We really need 3 as a fraction. So 3 over 1, change it to denominator 4, that will be 12 over 4. Subtract, we get 9 fourths. Y to the 5 minus 2 fourths, or 1 half. Okay, 5, change that to a denominator of 2, 10 over 2. That's 9 halves. There's my final answer.